and I'm presenting That's Some Salty Shrimp. The background to this experiment is that these little aquatic creatures called brine shrimp that measure between 3 and 8 millimeters in length help clean contaminants from our ecosystem. Salinity is the concentration of dissolved salt content in the water. This is a major factor in how salt the oceans are. And there's a problem now with our Earth where the salinity is high, where usually the water is low, and where it is low when it's usually high. This is causing problems in the ecosystem and causing shrimp and other aquatic creatures to move to other places with different salinity concentrates, or it causes the species to die off. The purpose of this experiment is that since these recent changes have been happening to the Earth, plus the numerous amount of waste that is dumped into the water, demonstrate that cause and effect on a certain species, and I chose brine shrimp. My hypothesis for this experiment is that the continuous increase of salt will cause the shrimp to be more aggressive, while the changing food source will cause the shrimp to die, while the shrimp in another tank with no changing environment will repopulate and the death rate will be small. The materials you need to do my experiment are rubber gloves, a big spoon, measuring spoons, a 2-liter fish tank. This is also a heater sticker. It tells you how warm or how cold the water is. That's important. You need some Epsom salts, 2 liters of water, wide range pH and total chlorine test strips, marine salt, aquarium heater, an air pump with airline tubing and an air stone. So, to do the experiment, before you add the water to the fish tank, you'll need to test the water for pH and chloramines. Chloramines are usually put in water to clean it, and if they are in the water when you do the experiment, the shrimp will not hatch. So, you take the test strip, take one, dip it in the water, you leave it in there for 10 seconds, shake it off a little bit, and you wait, and it is 0, so that means there are no chloramines in the water. When you get the test strips, you want to make sure it is total chlorine, because if it is not total chlorine, then you might not get the results you need to say if there are chloramines or any other contaminants in the water that might hurt the shrimp. Then you take your pH one, wait 30 seconds, alright, and then you compare it to the side, and it says that the pH is 7, and the pH needs to be 8 for the experiment. So that's where the Epsom salts come in. After you add your 2 liters of water, I recommend getting bottled water because most tap water does have chloramines in it. You can find out if your water does have chloramines in it by testing it, or you can call your town and ask directly. They should have the information for you. It's very easy to change the pH of the water. Make sure you add 2 liters of water into the tank, because that's how much it needs, or else the shrimp will not have enough water to survive. After you take your test water, you dump it down, sink. Then time comes to add the salts. So you want to add 2 tablespoons of marine salt. You can usually find this at your local pet store, or you can order it offline. These are usually used for tanks with fish in them. And then this is where the Epsom salts come in, because the Epsom salts can change the pH and make it to 8 or higher, depending on what the pH level is. You need to add half a teaspoon per liter, so we're going to add a whole teaspoon because we have 2 liters, and this will raise the pH of the water to 8, which is where we need it to be. After you add all the salts, you stir until it dissolves in the water. You want to make sure you get rid of all those big chunks of salt if there are any, and this will make the salinity right in the water so the shrimp can hatch. This may take a little while because dependent on how big your tank is, it all varies in the salt ratio. If for whatever reason the salt gets in the tank, just use the edge of the spoon and move that salt right out of the way so it all dissolves. Once it's done dissolving, you want to put your rubber gloves on. Take the heater, unwrap the cord, and stick it into the tank. Now each aquarium heater is different. This one is submerged under the water. Some might be above, some you have to position a certain way. This one just needs to be submerged. Make sure when you have your heater though that you tie a knot at the end of the cord, so if any water does escape the tank, that it does not go into the cord and shock you or cause any electrical damage. Then, after you add the heater, you add the air stone, connect it to the air pump. It's very easy. You just connect the tubing to the stone and the pump. Do not plug the air pump in because the vibrations from the pump do cause a disruption in the shrimp eggs and causes them not to hatch. This happened before and this did not cause the shrimp to hatch, so I had to do it again without the air pump running, and they did hatch. I recommend letting the water heat up before you add your shrimp eggs. And then once the water is between 80 to 82 degrees, you add your shrimp eggs into the water, and the shrimp should hatch between 24 to 48 hours. It depends how long that you have stored the shrimp. You can store the shrimp long term by putting the eggs in the freezer, but that may affect how long it takes for them to hatch. And shrimp eggs usually stay, well, not freezer between 1 to 3 weeks. So, once you add the shrimp to the water and let them hatch, you do the same thing for the second tank in the experiment, and you wait 1 to 2 weeks for shrimps in both tanks to mature, because if you start changing the environment right away, they will die immediately because they're not mature yet. So after the 2 weeks is up, you start increasing the salinity in the water in tank 2, and also you give them food waste or scraps, whatever, like leftover banana peels, carrots, stuff like that. And that's going to be their food from now on in tank 2, while in tank 1 you continue to feed the shrimp yeast every day, and you feed the shrimp twice to 3 times a day. Do not overfeed them because then they will start gunk getting into the tank and you'll have to clean it, and it will be a very tedious task because the shrimp are so small. And then you record observations, death rates in your journal, and that is how you do my procedure. And data collected from this experiment showed that in tank 2, a total of 62 shrimp died in a 2-week period. Tank 2 is where the environment was constantly changing, and where they were fed food waste and the salinity in the water was increasing. While in tank 1, the non-changing environment, a total of 5 shrimp died in the same time period. The goal of the experiment was to see how the increased salinity in the water and the food waste would affect the survival rate of the shrimp in Tank 2 compared to a normal environment, so in Tank 1. It shows that the shrimp could not handle living in an environment with increased salinity and a change in food source. But this is contradictory to the research I did prior to the experiment, where I found that brine shrimp are able to live in an increased amount of salinity in the water, but this was proven false as seen in graph 2, where as the salinity increased in the water, more shrimp died over time. As seen in picture 1, you can see that the death rate was much smaller in Tank 1 than in Tank 2. It is also contradictory to the research that males aren't really found in brine shrimp colonies. This proven to be false in Tank 1 because many of the shrimp mated with one another, which is actually goes parallel with the research because the Tank 1 environment was perfect mating and breeding conditions for the shrimp. None of the shrimp had offspring in Tank 1, but they did mate. Also, in Tank 2, only 2 shrimp mated, but they did not live either. Also, the color of the shrimp changed over time in Tank 2. Instead, they turned a gray, almost translucent color in Tank 2 because their bodies could not absorb and excrete ions in the water, which caused them to die. While in Tank 1, as seen in the photos, they were a pink salmon color, which proves that they were healthy and well-being. Errors that occurred in this experiment that may have affected the results were that the salinity content in Tank 1 may have been a bit off than when the experiment started. When water would evaporate from Tank 1 and the water levels would get low, I would add water and add Epsom salt to increase the pH so it was right, but I did not add the amount of marine salt, which could have caused the water to be fresher than when the experiment started, which could have caused the shrimp to mate more and caused them to live longer than if the salinity content was the same, continuous throughout the experiment. Another error that occurred is that Tank 2 was slightly colder than Tank 1. Tank 1 remained at temperatures between 80 to 82 degrees, while Tank 2 remained at temperatures between 79 to 81 degrees. This could have affected the survival of the shrimp in Tank 2, causing them to die of coldness rather than starvation or salinity in the water. Another error that occurred is that the light source may have been off in the room where I kept the shrimp. There are no blinds on the windows where I kept the shrimp, so it could have caused uneven lighting throughout the day and caused some of the shrimp to get less lighting than others. Also, if I could redo this experiment, I would have started the experiment earlier, adding more time to the experiment, letting me collect more data and results. Also, cause the shrimp to see how the death rate would actually be over a continuous period, because brine shrimp live regularly on a span between 2 to 3 months. Also, if I could redo this experiment, I would add a predator to the waters to see if the shrimp would work together as a team against the predator or if they would fend for themselves. I think this would add more data to the project and add more results on the death rate and how well shrimp survive in an environment. In conclusion, the accumulative data supports the hypothesis because, as shown in the graphics and the pictures provided, that the shrimp that lived in Tank 2, the constantly changing environment, could not adapt or survive in the increasing salinity and the food waste in the water, while the shrimp in Tank 1, the non-changing environment, prospered tremendously and mated with one another. The data shows that humans should find a better, effective, and environmental-friendly way of throwing away waste instead of dumping it into the oceans. Because if we humans continue to add more waste to the waters, it will continue to affect the ecosystem and cause all the life in the ecosystem to die.